the first step, it says we have dollars saved versus days passed. So these are the days, these are how many dollars we end up saving after a certain number of days. So the first step is to plot the data and make a line of best fit. So in my data, I'm going to go over by ones. And I think up by twos is probably good. Let's see. Two. Yep, we can go up by twos. And from there, just plot the points. So 0, 5, 2, 9, 4, 11, 6, 10, 8, 15, and 10, 24. It also says construct a line of best fit. So we're going to take a ruler and just estimate a line that fits the data the best. My line is going to be something like this, but as we know, every line of best fit is a little bit different. But mine is right there. Next step, find the equation for the line of best fit. So to find the equation, we need to find the slope and the y-intercept. So my slope we get from a sloped triangle. So we pick any 2 points on the line, any nice 2 points. So this one looks to be a nice point, and this one looks to be like a nice point. So I'm going to draw my sloped triangle. And our slope is the change in y over the change in x. So my change in y, it goes up by 2, so it's 2, 4, 6, 8, 10. My change in x goes over by 1s. So mine is 1, 2, 3, 4, 5, 6, 7. So I get 10 over 7. And if we put that into a calculator, we'll get about 1.4. My y-intercept is where the line starts, which is at 5. So my equation is y equals the slope, which is 1.4, times x plus the y-intercept, which is 5. From there, the next step says solve the equation and find the residuals. So all we do is to find our estimated output. There are 2 ways we could do it. One way is we could plug these numbers into the equation, and I'll do that way. So all we do is 1.4 times our input, 0, and then plus 5. So my estimated output using my equation is 5. And then I plug the next number in. So I get 1.4 times 2 plus 5. And that equals, that's not right, 1.4 times 2 plus 5 equals 7.8. And then we do it for 4. 1.4 times 4 plus 5 is 10.6. 1.4 times 6 plus 5 is 13.4. 1.4 times 8 plus 5 is 16.2. And lastly, 1.4 times 10 plus 5 equals 19. So that's our estimated data. That's the data we got from an equation that we got from our line of best fit. And the last part is to find the residual. Remember, the residual is actual data, which is right here, minus estimated data, which is right here. So we do the actual data minus the estimated data. So my first residual is 5 minus 5, which equals 0. My next one would be 9, which is my actual data, minus 7.8, which is my estimated data, and I get 1.2. My estimated data is from my equation, which I got from my line of best fit. And this line estimates these points. And so I continue. My actual data is 11, minus 10.6 is 0.4. My next one is 10 minus 13.4, which is negative 3.4. My next one is 15 minus 16.2, which is negative 1.2. My next one is 24 minus 19, which is 5. From there, we can graph our residual plot. To graph our residual plot, all we do is graph our residuals. On this one, I'm just going to go up by ones, down by negative ones, and across by ones. So at 0, my residual is 0. At 2, my residual is 1.2. That's about right here. And I'll zoom in a little bit so you can see what I'm doing. At 4, sorry, that should be right here. My bad, I messed up. So at 2, my residual is 1.2. At 4, my residual is 0.4, which is about right here. At 6, my residual is negative 3.4. So 4, 5, 6, that's right here. So that point is at about right there. At 8, my point is at negative 1.2. So 8, negative 1.2. And you can write numbers on these if you want. And lastly, at 10, my number is 5. So 1, 2, 3, 4, 5. So as you can see, there's no pattern in our residual plot. It's not a straight line, right? The points go all over the place. That's a good thing. So we can write, since there is no pattern in the residual plot, our line of best fit is a good fit. And that's what we do for the first part. All right, so I'm looking at part 2, the upper bound and the lower bound. The first part says create a scatter plot on the graph below. I already went ahead and did that. The next part says find the LSRL and write it below. So in this part, you have to Google LSRL calculator, and then you click the first result. You input the data, put a space between each number, and click generate equation, and you will get something that looks like this. Y equals 4.33 plus 1.6 times x. So on this, we understand that our y-intercept, is that 4.3, and our slope is that 1.6. So our equation will end up being y equals 1.6 times x plus 4.3. In the example on the LSRL, on the calculator, we end up getting, sorry, give me a second. We end up getting 4.33 plus 1.6x. So all we did, as you can see, is we put the 1.6x in front and the 4.3 on the back. Doesn't make any difference. So from there it says use your LSRL to complete the table and then graph your LSRL in another color. So now we're going to use our LSRL to complete the table below. So all we got to do is plug these numbers right here into the LSRL and graph them. So I'm going to do the equation, which is 1.6. So 1.6 times 0 plus 4.3 gives us 4.3. And then I do 1.6 times 2 plus 4.3, and I get 7.5. And then I do 1.6 times 4 plus 4.3, and I get 10.7. And then I do the same thing, 1.6 times 6 plus 4.3 gives us 13.9. And 1.6 times 8 plus 4.3 gives us 17.1. And lastly, 1.6 times 10. 1.6 times 10 plus 4.3 gives us 20.3. And we graph those points on the line and connect the dots. So 0, 4.3 is probably about there. 2, 7.5 is probably about right here. 4, 10.7 is about right here. 6, 13.9 is about right here. 8, 17.1, probably going to be about right here. And the last one, 10, 20.3, probably about right there. So we have an almost perfectly straight line. So you connect those points, and that'll give you our graphed LSRL. And the last part, or second to last part I should say, complete the table to find the residuals. So the residual, as we remember, is the actual data minus the estimated data. This is our actual data, this is our estimated. So 5 minus 4.3 is 0.7. 9 minus 7.5 is 1.5. 11 minus 10.7 is 0.3. 10 minus 13.9 is negative 3.9. 15 minus 17.1 is negative 2.1. And 24 minus 20.3 is 3.7. Now, this is the last part. To find the upper bound and the lower bound, it says circle the biggest residual on the graph and draw the upper and lower bounds, then complete the table. So my greatest residual is probably this negative 3.9. So I'm going to circle that negative 3.9. That's the greatest number. So 3.9 is farther from 0 than 3.7. That's why I'm circling that one. And then I'm going to circle that same point on my graph. So 6 is right here. So I'm going to circle that point. And then I'm going to draw a line that goes through that point. And that's going to be my lower bound. So I take my ruler and draw a perfectly parallel line through that point. Right there. And that's my lower bound. And then I'm going to do the same thing, the same distance, but above it. So I see this is about 2 squares, so I'm going to have a ruler about 2 squares above it as well. And that should be about right there. And that's my upper bound. The upper bound or the other one does not need to go through a point. It's just a coincidence that it does. The main idea is that our second boundary line needs to be the same distance as this one is. That's why they're perfectly on the other side. It looks just like a road. So from there, to find the upper bound and lower bound, we just go to that point. The upper bound is this one. The lower bound is this one. So at 0, my upper bound is at about 8. And my lower bound is at about, I'd say 0.5 maybe. At 2, my upper bound looks to be at about 11.5. My lower bound is at 4. At 4, my upper bound looks to be about 14.5. My lower bound at 4 looks to be about 7. At 6, my upper bound is 18, I think. 18, yep, 18. And my lower bound looks to be at 10. On 8, my upper bound is 21, and my lower bound is 13. And lastly, at 10, my upper bound is at 24, and my lower bound is at 16. And that's that. So, if you need help on that more, I would re-watch this video and then ask somebody at your group. Bye.